Hello everybody. So today I will talk about calculus. The topic today is about differential equations. So now I will show you how to answer. In this situation, I need to create about complementary solution and particular solution. So about complementary solution, for this one like this, I will put about yc equals to e to the power of lambda s. So if I do first the derivative of yc, we do first the derivative of this one. So we have lambda e to the power of lambda s. Because if I do first the derivative of e to the power of lambda s, we keep about this one. And later that we do first the derivative of lambda s. So you got about lambda. Now we do second derivative. We have lambda square e to the power of lambda s. And we have third derivative. We have lambda to the power of 3 e to the power of lambda s. Now we put this one to change about this one in here. But this is about complementary solution. So this one should be equal to number 0. So this one we have lambda to the power of 3 e to the power of lambda s. This one we have lambda square lambda e to the power of lambda s, and we have lambda e to the power of lambda s, and the last one that is about 2e to the power of lambda s. So we can do about factorization of this one in here. So we need to find the solution of this one. So if we calculate about this one, we have 3 solutions. So we have negative number 1, number 2, and positive number 1. So we have yc equal to c1 e to the power of, we have negative number 1, so we have negative s, c2 e to the power of 2s, and c3 e to the power of s. Now we go to particular solution. About particular solution, we have 6e to the power of 2s. But if we look carefully about complementary solution, we have e to the power of 2s. So about yb, we need to put capital A s e to the power of 2s, because we just have e to the power of 2s in here. So about particular solution, we need to increase more than one level. So that's why we need to multiply by s. Now if we do first the derivative of this one, we do first the derivative of s multiplied by e to the power of 2s. Later that we do first the derivative of e to the power of 2s. So we have 2s e to the power of 2s. We do second derivative. So we do first the derivative of this one. Now we do first the derivative of s. And we do first the derivative of this one. So this one plus this one, we have 4. Now we go to third derivative of the function. So if I do first derivative of this one, we have 2e to the power of 2s. We have 8e to the power of 2s. We do first derivative of s, so you have number 4 e to the power of 2s. We do first derivative of this one, we have 8s e to the power of 2s. 8 plus 4, you got about 12. Now we put everything in here. Go to this equation. So we now put everything based on the term of e to the power of 2s and s e to the power of 2s. About e to the power of 2s, we have 12a. Next, we have for a with negative number 2, we have negative 8a. This one we have negative and we have a, so we put a in here. And the last one 2y we don't have, so we just have this one like this. Now let's go to s e to the power of 2s. So we have this one, we have a and we have 8a. Second derivative with negative number 2. Negative number 2 with number 4, you got about negative 8a. First derivative with the negative sign. So we go to first derivative, we have number 2. So that should be about negative 2a. And number 2 with a, we have 2a. This one negative, not positive, sorry. So we simplify. 12 minus a minus 1. You got about 3a. This one in here, they cancel. So that should be about 6 e to the power of 2s. So 3a in here equal to number 6. So we can find the value of a. That's about 6 divided by 3, and we have number 2. After we got number 2 in here, we go back to about yb and we put number 2 in here. So y equal to yc plus yb. So yc, we just copy from here. And yb, that's it from here. Now we change capital A into number 2. And this is the final answer. This is the end. Thank you for watching.